Hello everyone. So kule video discuss another type of a function, which is the hyperbolic function. So the hyperbolic function is a function in the form y is equals to a over x, where a cannot be 0 and x cannot be 0, also y cannot be 0, right? So the hyperbolic function is in the form a hyperbolic function is a function that is in the form y is equals to a over x, where x cannot be 0 and y can not be 0 also, right? A also cannot be 0, right? So now there's also other forms of the hyperbola, right? But then the other forms come from this standard form, right? So this is the standard form of a hyperbolic function, right? It has vertical and horizontal asymptotes, right? We said that x cannot be 0, meaning that the graph cannot have an x-intercept in this form, right? And then we also said y cannot be 0, meaning the graph cannot have y-intercept in this standard form, meaning the lines y equals to 0 and x equals to 0 will be the asymptotes, right? The graph can never ever cross or touch those lines. They can only approach, right? Now, depending on whether a is positive or not, the graph will lie on the first and the third quadrant, right? If a is let's check. If a is positive, the graph will lie in the first and second quadrant and the third quadrant. And then if a is negative, the graph will lie in the second and fourth quadrant, right? So this is when a is positive, and then this is when a is negative, right? This is when a is negative. So now the other forms of the hyperbolic function will be y equals to a over x minus p plus q, right? So now notice with this form of the hyperbolic function is simply a transformation of this standard form, right? You can maybe say that to get to this form here, we shifted the graph of the standard hyperbola horizontally by p units and vertically by q units, right? So in this form, now your vertical and horizontal asymptotes will be x cannot be equals to p, so your vertical asymptote will be x equals to p, and y cannot be q, so your horizontal asymptote will be y equals to q, right? And then now in this form, let's say maybe p is equals to 5 and q is equals to 3, right? And then in this form, your vertical asymptote will be at x equals to 5. Let's say this is 5, and then at your horizontal asymptote will be y equals to 3, right? Let's say this is 3, and then let's say a is positive, so the graph will lie in these quadrants, right? So this will mean we shifted okay, so using those values of p and q, it means our function will be a over x minus 5 plus 3, right? This mean this form means we shifted the standard form y equals to a over x by 5 units to the right, and by 3 units up, right? So yeah, That is the hyperbolic function. Now let us read the properties of the hyperbolic function. We did say it is in the form y is equals to a over x. Now the other forms of the hyperbola, where you see p and q, they are simply transforming this standard form, right? So yeah, in fact, for all the other functions, even for the line function or the line graph, the standard form will be y is equals to x, and then the other forms, they are simply transforming this standard form, right? The other forms, y equals to mx plus c, they are simply transforming this original form by changing the gradient and by making vertical shifts on the function. And then the standard parabola will be y equals to x squared. The other forms, ax squared plus bx plus c, they are simply transforming this original form, right? So it's the same thing with the hyperbola. The standard form is y equals to a over x. The other forms we are simply transforming by shifting this original form by p units horizontally and q units vertically, right? So now let us go to the properties of the hyperbolic function. The shape is determined by the value of a. If a is positive, the graph will lie in the first quadrant and the third quadrant. If a is negative, it will lie in the second quadrant and the fourth quadrant. Now the domain and the range will depend on the values of the horizontal and vertical asymptotes, right? No, so for the standard function or the standard form of the hyperbola, which is this one, y equals to a over x, the domain will be all x values but excluding the vertical asymptote, which is why they say is the domain is x element of real numbers, but then x cannot be 0. What happens if you divide by 0? Lapago denominator, you will have undefined. So which is why we are excluding 0 from the element of real numbers, from all the sets of real numbers, right? And then the range is also all real numbers but excluding the horizontal asymptote, right? The graph can never ever cross or touch the horizontal asymptote, which is why we have to exclude that y value there. So the range is all real numbers excluding the horizontal asymptote. Okay, let us sort of try to understand the domain and range of a hyperbolic function, right? The hyperbolic function of the form y equals to a over x. Like, let's say a is positive, let's say a is 2. For argument's sake, let's say a is 2, which means now our function is f of x or y equals to 2 over x, right? And then we're saying okay, let us draw a quick sketch of this function. We know a is positive, so our graph will lie in the first quadrant and the third quadrant, right? And then we so it is the standard function, right? This is the line. The vertical line is the line x equals to 0, so that is our vertical asymptote. So the vertical asymptote is the line x equals to 0, and the horizontal asymptote is the line y equals to 0, right? So this vertical line is the line x equals to 0. So whenever they ask you to write down the equation of the asymptotes, you have to write down, depending on the question. Let's say maybe the question says write down the equation of the asymptotes. They don't specify if you write down the equation of the vertical or horizontal asymptote. Then you will have to write both equations. So if they say write down the equation of the vertical asymptote, you will say x equals to, depending on your asymptote, in this case the asymptote is the line x equals to 0. The vertical asymptote is the line x equals to 0, and the horizontal asymptote is the line y equals to 0. This is the equation of the horizontal asymptote, and this is the equation of the vertical asymptote, right? So now, depending on your asymptotes, you can now determine the domain and the range of this function, right? So now we're saying the graph exists everywhere, but then x cannot be 0, which means x can be anything except 0 for this graph to exist, which is why we don't have an x-intercept, because the line which is why we don't have a y-intercept. Remember, when you determining a y-intercept, you have to let x be 0, but then in this case x cannot be 0, which is why we don't have a y-intercept. The same thing, the same explanation for why we don't have an x-intercept is because to have an x-intercept you have to let y be 0, but then the line y equals to 0 is our horizontal asymptote, so the graph can never touch those two lines. So which is why our graph doesn't have any x and y intercepts, right? Now coming back to the domain and range, so we'll say the domain is all the real numbers for x, but then x cannot be 0. If x is 0, which will mean our function will be 2 over 0 at some point, which is not possible because we cannot divide by 0, right? And then the range we're saying is y element of all real numbers, but then y cannot be 0, right? Why can we not have y as 0 there? So if we have y as 0, which will mean we'll have if we have y equals to a over x as our function, and then we have a possibility for y being 0, it will mean at some point we'll have a b being 0, which is sort of not possible, because a can be greater than 0 or a can be less than 0, but then a can also not be 0, right? From the definition of the hyperbolic function, you see lapha they say a cannot be 0. So if it happens y is 0, it will mean a can also be 0, which is not possible for this definition to apply. Okay, I hope that makes sense. So now the domain and the range for the hyperbolic function will depend on the values of the horizontal and vertical asymptotes, right? So for this form, for the form y equals to a over x, the domain is x element of real numbers, but then x cannot be 0. And for the form y equals to a over x also, the range is y element of real numbers, but then y cannot be 0, right? Now for the other forms of the hyperbolic function, let's take the form y is equals to a over x minus p plus q, right? The range and domain will also depend on the values of the vertical and horizontal asymptote. Now if they ask you to write down the equation of the asymptotes in this form, let's take some random numbers so that we can have actual numbers to work with. Let's say a is 3 and then let's say P is 3, or let's say P is 2, and then let's say Q is 1, right? So now if they ask you to determine the domain and the range, it will depend on the values of the asymptotes, right? And then let's say they ask you to write down the equation of the asymptotes. You'll say the vertical asymptote is x equals to 2, right? Because if you let x be 2, you'll have 2 minus 2 in the denominator, which will be 0, and we cannot have 0 in the denominator, right? So now x equals to 2 is your vertical asymptote. Your horizontal asymptote is the line y equals to 1, right? So is the line y equals to 1, so which means the graph cannot cross that line. And then now to determine the domain and range, it will also depend on the values of the asymptote, right? Now the domain for this type of a hyperbola will be x element of real numbers, but then x cannot be the asymptote, x cannot be 2. The range is y element of real numbers, but then y cannot be 1, which is that asymptote there. Okay, I hope it makes sense. Okay, let us continue with the properties of the hyperbola. We did talk about the shape. If A is positive, our graph will lie in the first and third quadrant. If negative, it will be second and fourth quadrant, right? And then we discussed the range and the asymptotes, right? We also have the lines of symmetry, y equals to x and y equals to minus x. So here we have those lines, y equals to x and y equals to minus x, right? There will be questions where they want you maybe to write down the equations for those lines. So it's easy for the standard hyperbola, because you know what it's y equals to x if our graph lies in the first and third quadrant, and y equals to minus x if our graph lies in the second and the fourth. But then for the other forms of the hyperbola, these lines of symmetry will also change, right? So to find an equation of those lines, the gradient will always be minus 1 or 1, right? So which means the equation for your lines of symmetry will be in the form y equals to minus x plus c, or y equals to x plus c, right? This one is for when your graph lies in the second and the fourth quadrant, right? It has a negative gradient, which means it's a decreasing function. And this one is for when your graph lies in the first and the third quadrant, right? Which means it has a positive gradient of 1, right? The gradient will either be minus 1 or 1 for these lines of symmetry. So for the other forms of the hyperbola, the next thing that you'll need to do is to determine the value of c, which is the y-intercept. For the standard form, like in this case, this is the standard graph for the hyperbolic function. For the standard form, this line will be minus x, because the x-intercept the y-intercept, is 0, which means c is 0. So it's minus x plus 0, which is just minus x. And then again, for this standard form, the y-intercept is 0, which means your line of symmetry will have this equation. But then for the other forms, to determine the equation, you will have to see where the horizontal and vertical asymptote intersect, right? So where they intersect will sort of give you the coordinates to be able to determine this equation, right? So notice with here they intersected 0 and 0, and then here again they intersected 0 and 0. But then for the other forms, let's say for the form y equals to 3 over x minus 2 plus 1, your asymptotes will be, the vertical one will be x equals to minus 2, y equals, the horizontal one is y equals to 1. So a is positive there, and then now our asymptote is x equals to minus 2. This will be minus 2. Sorry, this is 2, x equals to 2, and then the horizontal one is y equals to 1, right? And then we see Uti a is positive, so our graph will lie in the first quadrant and in the third quadrant. At some point this line will have, at some point the graph will intersect at some point we will have a x and y intercept, right? So now to determine the equation of the line of symmetry, we know what it will look like this, right? Okay, things are moving to a straight manner. It will look like this, and then now we know what it will be in the form y is equals to x plus c. Our gradient is 1 because it's an increasing function, right? Now to determine the value of c, you only need this to know the coordinates of that point where the two asymptotes intersect, right? So we know what the coordinates of that point is. X is 2 because of that equation, and y is 1, right? Now you can be able to determine the value of c by simply substituting those lines. We know what y is 1 and x is 2, right? So now the value of c will be minus 1. So it means this graph, so it means this graph will intersect the y-axis at minus 1. So my sketch should sort of look like this. It will intersect the y-axis at minus 1. So that will be your minus 1. So now the equation of the line of symmetry will be y equals to x minus 1. Okay, I hope it makes sense. Now going on to sketching the hyperbola of the form. To sketch the hyperbola, you need the equations of the vertical and horizontal asymptotes, and then you need to calculate the x and y intercepts, and then you need to know the value of a to determine in which quadrants your graph will lie. So now okay, here Lago activity 4 they are plotting, but then that is not the easy way or the smart or the quickest way to go about it, because if you plot you'll waste time in the exam. And yeah, so now we need to sketch. Here they are plotting, but then now we need to sketch. We don't have to plot every single point. We just need to know the critical points, which are the x and y intercepts and your equation of the asymptotes. Those are the points that you need to be able to sketch a hyperbolic function. If you are plotting, you'll be wasting time in the exam. So now we already spoke about the hyperbolic function in this form, right? Notice with it that the hyperbola of the form y equals to a over x plus q is the translation of this standard form vertically by q units, right? And then for the other form, they are for this form they are translating the graph Q units vertically and P units horizontally, right? We already spoke about the shape. We already spoke about the shape. If A is positive, we said our graph will lie. If A is positive, we said our graph will lie in the first and the third quadrant, and if A is negative, it will lie in the second and the fourth, right? Yeah. So now let us go on to activity 6. Activity 6. Okay. Okay, so here we have activity 6. This is question 1. But consider the function f of x is equals to 2 over x minus 3 plus 1. And then Batini, write down the equation of the asymptotes. I know what the vertical asymptote is the line x equals to 3, because x cannot be 3. Otherwise, if we allow x to be 3, we'll have 3 minus 3 in the denominator, which will be 0, and we cannot have 0 in that denominator. And we know what our horizontal asymptote is the line y equals to 1, right? And then going to B Batini, calculate the coordinates of the x and y-intercepts of f. The y-intercept, we know what we let x be 0, and then we'll have f of 0 equals to 2 over, wherever I see x I put 0, minus 3 plus 1, so this will be minus 2 over 3 plus 1, which will be 1 over 3, right? So now these are the coordinates of my y-intercept, 0, 1 over 3, right? And then the my x-intercepts, I have to let y be 0, which means f of x equals to 0. I know f of x is 2 over x minus 3 plus 1 is equals to 0. And then now I simply need to solve for x. Transposing, I need to solve for x. Taking 1 to the other side will be minus 1, and then cross multiplying, I'll have 2 equals to minus x minus 3. And then I know what I'll have 2 equals to minus x plus 3, and then taking x to this side, I'll have x. Taking 2 to the other side, I'll have 3 minus 2, which is 1. So meaning my coordinates of the x-intercepts will be 1, 0, right? So now moving on to question C. Question C, they want us to write down the domain and the range. The domain is x, element of real numbers. Okay, to save space, I think I'll see la peconin. Okay, see, we know what the domain is, x, element of real numbers, but then x cannot be equals to the vertical asymptote. And then the range is y, element of real numbers, but then y cannot be equals to the horizontal asymptote, right? And then now with they want us to sketch. So we have the critical points, we don't have to plot, né? So let me show you how we plot. We sketch using the x-intercepts and the horizontal and vertical asymptotes, right? So we start by drawing the asymptotes. You go to x equals to 3. Let's say this is x equals to 3 here, and then you draw your vertical asymptote, right? You draw your vertical asymptote. Right, so this is your vertical asymptote where x is 3, né? And then now you know what your horizontal asymptote is, the line y equals to 1. Let's say this is 1, y equals to 1, and then you sketch, you draw your horizontal asymptote, right? And then now you see what a is positive, a is 2, so we know what our graph will lie in the first quadrant and the third quadrant. So now we know what we will have a piece here because our graph will lie in the first quadrant and the second quadrant, but then it can only approach the asymptotes, it can never touch the asymptotes, right? And then now we have our x and y intercepts. Now I know what my x-intercept is this point, x is 1, y is 0. Let's say that point is somewhere here, x is 1, y is 0, and then my y-intercept is the line, is the point 0 and 1/3, that is somewhere here. And then now all I have to do is to connect these 2 points, right? And then after that I just label my axis. This is my y-axis, and then this is my x-axis, right? This is my asymptotes, and then I'm done. Okay, so did you see how quickly that was? I didn't need to plot the points by drawing a table, going to my calculator, calculating maybe substituting x and getting y. So as long as you have the critical points, which is the x and y intercepts and your asymptotes, you will be able to draw a quick sketch of a hyperbolic function. Right, now let's go to question 2. Okay, question 2. So question 2, I think consider the function f of x is equals to 3 over x minus 1 minus 2. Write down the equation of the asymptotes. I'm sure by now we know what we look at the vertical and horizontal asymptotes. And then we know what the vertical one is, the line x is equals to, look at the denominator. If we say x is 1, we'll have 1 minus 1, we'll have 0 in the denominator, but right, which is not allowed. So the line x cannot be 1, so the line x equals to 1 is our vertical asymptote. And then the horizontal asymptote, we just look at the value of q there. We know what the horizontal asymptote will be the line y equals to minus 2, right? Now going on to question B, they want us to calculate x and y intercepts. So the x-intercept, the y-intercept, we know what we let x be 0, so which means I will have f of 0 equals to 3 over, wherever I see x I put 0, minus 2. So I'll have 3 over minus 1, which is just minus 3, minus 2, that will be minus 5. So now 0 minus 5 is the coordinates of my y-intercept, right? And then the x-intercept, I let y be 0, which means I'll have f of x be 0. I'll have 3 over x minus 1 minus 2 to be 0, and then I just solve for x. I transfer 2 to the other side. I will have 2. I transfer minus 2. I'll have 2, and then I cross multiply. I'll have 3. 2 times x minus 1, and then I'll have x equals to 3 over 2 plus 1. 3 over 2 plus 1. 3 over 2 plus 1, that will be equals to 5 over 2, right? So the point 5 over 2, 0 will be the coordinates of my x intercept, right? So now question C, they want us to sketch the graph. So notice after they ask you to determine the equation of the asymptote and calculating the x and y intercepts, they ask you to sketch the graph, right? So which means at this point you have all the information that you need to sketch the graph. You have the x and y intercepts, and you have the equation of the asymptotes. That's all you need to sketch a hyperbolic function. So now let us sketch. So we have our asymptotes. X equals to 1. It is somewhere there. X equals to 1, and then y equals to minus 2, somewhere here. This is 1. This is minus 2, right? And then our A is positive, so our graph will lie in this quadrant and in that quadrant, right? And then now let us plot our intercepts. Our y-intercept is minus 5. Minus 5 is somewhere there. And then our x-intercept is 5 over 2. 5 over 2 is somewhere there, right? Now all we have to do is extend to get our graph, right? Okay, yeah. And then I label my axis. This is my y-axis, this is my x-axis. Okay, and then now write down the range of y equals to minus f of x. So this is a reflection of this graph about the x-axis. So now writing down the range, if you reflect this line about the x-axis, it will mean this piece will come above, that piece will sort of come below, right? But then minus f of x is equals to minus f of x is 3 over x minus 1 minus 2. So this will become minus 3 over x minus 1 plus 2. So now the range of this function is y element element of real numbers, but then y cannot be equals to 2, cannot be equals to that 2. Okay, and then going on to question E, but it describes in words the transformation of f to get to g, where g is equals to minus 3 over x plus 1 minus 2, right? So if you say f of minus x in your original function, wherever you see x, you will put minus x, right? So yeah, remember when we started with this revision of functions, I did mention Uguti, this exercise here, where is it? This exercise here, although it is easy, but then you have to be able to interpret what is happening, right? So this is all about transformations. Notice ukuthi lapha ku minus ku 4.2 minus g of x is there, and then Tina in our question they asked about minus f of x. So you have to know what this means. And then Mina now in answering question E, I'm substituting minus x there. I'm saying f of minus x, and then we did have that in our very first exercise of this revision. So this exercise is important. You have to know how to interpret whatever that is happening here, right? So if you still don't understand what's happening here, ungazise lapho, so that I can explain to you. So now back to question E. So if I substitute minus x lapha with the original function, I will have 3 over minus x minus 1 minus 2, right? And then now factoring minus 1 out from the denominator, I'll have minus x plus 1, right, minus 2. Then that minus 1 I can bring to the numerator to have minus 3 over x plus 1 minus 2, which is the equation of g, right? So okay, I think create this space now. So lapha ku question E, to get to this equation yaga g, what is the transformation there? G of x is equals to f of minus x. What is f of minus x? It's a reflection of f of x about the y-axis, and then you get your 2 marks, right? Yeah, that is how you do it. So let me do one more activity. All right, let me do activity 7. Let me do activity 7 and then conclude hyperbolic functions, right? But the diagram below represents the graph f of x equals to a over x plus p plus q, and then t is a point on f. they want us to determine the values of A, P, and Q. And then okay, let me just copy this. And create space here. So activity 7, question 4.1, they want us to determine the values of A, P, and Q. Right, so 4.1, the values of A, P, and Q we can determine. So looking at the graph, we see our horizontal asymptote is the line y equals to -2, and our vertical asymptote is the line y equals to x equals to 4. So straight away I know P is equals to -4, right? And then Q is equals to 2, right? So now my equation becomes f of x is equals to a over x minus 4 plus 2, right? I got the values of P and Q by simply looking at the vertical and the horizontal asymptotes, right? From this diagram, I see the equation of the asymptote is x equals to, the equation of the vertical asymptote is x equals to 4, and the equation of the horizontal asymptote is y equals to 2. So I know x cannot be 4, which means I need to subtract. I will be subtracting by -4 lapha kule denominator, right? So yeah, that is how I got the values of P and Q. And then now I have my equation like this. I can use this point to calculate the value of A. So if I substitute I can use this point to calculate the value of A. If I substitute 5 in my equation, I know I should get 3, right? When x is 5, y has to be 3, right? So I will have, wherever I see 5, I'll put 3. I'll have a over 5 minus 4. Sorry, wherever I see x, I'll put 5. And then, yeah. And then I'll have a over 5 minus 4 is equals to 3, which means my a is equals to 3. So f of x is equals to 3 over x minus 4 plus 2. Right, to test this, let us substitute 5. In our equation to see what the, oh sorry, I made a mistake. I made a mistake here. So wherever I see x, I put 5. So I'll have a over 5 minus 4 plus 2 is equals to 3. So a is equals to 3 minus 2. So a is equals to 1. So my equation is f of x is equals to 1 over x minus 4 plus 2, right? So to test my equation, you can substitute 5 in here and see what you get 3. So if you say 1 over 5 minus 4 plus 2, we do get this 3. Okay. and then we go to 4.2. Okay, so 4.2, they say if the graph of f is reflected across the line having the equation y is equals to minus x plus c, the new graph coincides with the graph of y equals to f of x. Determine the value of c. So now I did mention the lines of symmetry will be in the form y equals to x plus c and y equals to minus x plus c, right? So, and I mentioned that line, those two lines, they pass through the point where the asymptotes intersect, right? So the line y equals to minus x plus c passes through the point where the asymptotes intersect. Now, Tina, what we need is to determine where does this line intersect the y-axis, which will give us the value of c, right? So the line is a decreasing function because of the gradient. The gradient is -1. If the gradient is negative, a straight line has a decreasing function, and if it's positive, it has an increasing function. So now the line passes through this point where the asymptote intersect, right? And then that point where the asymptote intersects, we know what the x is 4 and y is 2, right? And then we now that we have these 2 point, we have this point, the coordinates of this point, we can simply substitute them in our equation and solve for c, right? So we have y equals to minus x plus c, and then we have y to be 2 when x is 4. So to solve for c, we take 4 to the other side and have 2 plus 4 and have 6. So c is equals to 6 using that point where the asymptotes intersect. Okay, so I hope it makes sense. So now we can now conclude this section of the hyperbolic functions, and then next go on to the exponential function, right? I will make that for our next video. I'll make a lesson around exponential functions in our next video, right? If there's anything that you don't understand about hyperbolic functions, feel free to let me know or ask anything WhatsApp. And yeah, that will be it for this video.